This problem is nothing more than an expansion on the first problem from the first video. So with this one, after 5 years, you have a choice of trading in your vehicle. So you can trade it in the gas guzzler for the eco car for $15,000, or the eco car for the gas guzzler for $5,000, or you may keep your current vehicle at no cost. So that looks like this. So now we have a decision to make here, and then we have some probabilities. And then based on that probability, we can choose to either keep or trade based on whether it goes up or down. And then after that, after our decision, then we're subject again to two more rounds or two more possibilities here. So if the price goes up, we can choose to either trade or keep. And based on that, we will have some value. So in this, we have an 80% chance that the price continues on the current trend. So if it went up, it goes up, continues to go up. If it goes down, it continues to go down. And a 20% chance they change direction. Also, we have some slight changes to the costs and of the cars and of the operating costs based on, again, in real life, expected costs of depreciation, increased costs of vehicles, fuel, all that kind of stuff. So this is a fairly realistic problem here. So then when we get to this point, we can draw this all out, and then we're going to set it up like this. So we can see here the first part of this problem is already solved, right? So we've already solved for that part, but what we didn't solve for is we didn't solve for this second round. So the first video covers how I got to this point, and it, based on just one 5-year round of ownership, the gas guzzler saved us $200. But does that hold true? So in this, we have the price goes up, and then if the price goes up, I can choose to trade. If I trade, the cost is $15,000, and there's an 80% chance that the price continues to go up, and a 20% chance it goes down. I can choose to keep. The cost of keeping is 0, and if I keep the gas guzzler, then the cost is $10,000 in operating costs and $5,000 with, again, 80 and 20. So all I need to do for this is equals this times this, and that gives me the value of each of those. And I can just drag this down, autofill down, and I can take these out just a little bit quicker than typing that same formula many times. All right, now we can go ahead and take a look at this. So we have this probability times that value. So then for this one, it's going to be equals this plus this plus this. So you can see here, and let me zoom in a little bit. You can see what I'm doing. So then I have the cost of my trade plus the 80% times 3,000 and 20% times 500. And this would be the cost of trading. I can drag this down. This is the cost of keeping. So then I can drag all the way down here. And I have some values to remove. Autofill can save you a ton of time. All right, so it looks like we have everything correct there. So this is the cost of each of these. So then what we would do is we would make the decision that has the lowest total cost. So we'll take a minute and we'll look for that. So if the price goes up, then I would make the choice to keep. This would be my best choice. So we'll go ahead and choose that one. If my cost goes down, this one. If my cost goes up and I'm driving the eco car, I want to keep that. And down, it would be that value. So once I've gotten these, we actually use this number to replace this number. So this value becomes this value becomes this value becomes this, and this value becomes this. So now you can see that the total cost of owning the Eco Car, so we have these two, let me highlight those. So now the total cost is actually less for the Eco Car. And that's because I have, there's two drivers to this. One, this is now over a 10-year span. Also, I have the ability to react to the decision later. So we see this in problems where you have the opportunity to enter a market. You can enter that market at any time. You have to be able to estimate that kind of thing. Two different pieces of equipment, two different locations, things like that. That's where we use these. So this is a fairly complex one. Each of these only have two branches. We'll see some more examples that have more than two branches, but this is, as far as a academic exercise, this is a fairly complex problem. And that's all for this video.